Lesson 7.5, talking about roots and zeros, so the places where these polynomials cross the x-axis. In number 15 from your homework, you're being asked the question of how many answers am I looking for, and what would those types of roots be? Because it's x cubed, I know that I'm looking for 3 different solutions. How do I find them? Well, the first thing I can try to do is see if this can be factored. Looking at x cubed plus 9x, it does have a common factor of x. So I factor that out, I'm left with x squared plus 9 is equal to 0. We have 2 things multiplied together to be 0. One of them has to be 0. If it's the x, that makes life nice and easy because x is 0. If it's the x squared plus 9, subtract 9 from both sides, take the square root, and because we're taking the square root of a negative number, we're going to have 2 imaginary roots, positive and negative 3i. So how many solutions were there? There were 3. X equals 0 is a real solution. We would see that on our graph. Plus or minus 3i are still zeros. I can plug them in and the equation will equal 0, but it is not something that would show up on the graph. For number 20, I'm trying to figure out the number of positive and negative zeros. For that, we use something called Descartes' rule of signs. To make a prediction of how many times g of x crosses the x-axis on the positive side, all I have to do is look at the sign changes of the equation. It starts off as a positive, stays positive 8x squared, but then it changes. It is negative 4x. Right after that, it becomes a positive 3. So there are 2 sign changes. Now the pattern with Descartes is that it's the number of sign changes minus 2 until you reach 0. So how many times does g of x cross on the positive side? 2 or 0 positive roots. We can also make the same prediction with the negative side. So how many times it crosses on the left side of the x-axis. For that, though, we have to do a little more work. The first thing we need to do is figure out what g of minus x is. So wherever there was an x, I'm now going to plug in a minus x. We do have to simplify it before we count up the sign changes. Negative x cubed, 3 of them, so that is negative. A negative x squared, so 2 of them, is positive, times a positive 8 makes it positive 8x squared. A negative times a negative, so negative 4x times negative x is positive 4x. And then you have a plus 3. When you're done simplifying, we're looking for the same sign changes as we did before. Our polynomial starts off as negative 5x cubed, but then becomes positive 8x squared. Stays positive for 4x, stays positive for 3. So how many negative zeros might there be? 1. So 2 or 0 positive, 1 negative. It should add up to 3 because our original power was 5x cubed. So we've got all 3 accounted for. We now have stated the possible number of negative and positive zeros. The next thing we're going to tackle is number 32. We're going to find all of the zeros of each function. 32, I can't factor it, so x to the 4th, there has to be another way of breaking that down to x squared. Why do I want it as x squared? We can always find the zeros for a quadratic because we have the quadratic formula, or it might be something that we can factor. So how do we do that? Well, our first step in 32 is going to be to graph it. And what we're going to be doing is looking for where it crosses the x-axis. In 32, our graph crosses in two spots, x equals 4 and x equals -1. Now, if we were lucky, we would have seen all 4 places that it crossed, and then we would be done. But we're not so lucky. We only found 2. How are we going to find the others? We're going to go back to our bag of tricks from chapter 5 and use synthetic division. I'll put -1 in the box. Coefficients go next to it. And I'm going to use synthetic division to depress the polynomial. I drop the 1. -1 times 1 is -1. Add them together. -1 times -10 is 10. Add them together. -1 times 34 is -34. Add them together. -1 times -40 is +40. Add them together. So what have we accomplished? Our starting equation in 32 was x to the 4th. After doing our synthetic division, we have a new line of numbers. That line of numbers represents x cubed. So we knocked it down 1 power. But we're not there yet. X cubed, there's not much I can do with that either. So we're going to use the 4 and depress it 1 more time. So 4 is going to go in the box. I'm going to do synthetic division once again. I'll drop the 1. 4 times 1 is 4. Add them together. 4 times -6 is -24. Add them together. 4 times 10 is 40. Add them together for 0. So now we have another line of numbers. 1, -6, and 10. What does that represent? That represents x squared minus 6x plus 10. The reason we want it to be x squared is because if I cannot factor, I can also always use the quadratic formula to get any remaining answers. So if I do that here, my a value can be 1, b will be -6, c will be 10. I get the opposite of b, so 6 plus or minus the square root. B squared is 36 minus 4 times a times c all over 2a. Don't try to do everything in the quadratic formula at once. If you just tackle the radical, you get 6 plus or minus the square root of -4 over 2. Don't let the negative scare you. You know there's just going to be some imaginary numbers. So my other 2 solutions are going to be 6 plus or minus 2i over 2. And then since 2 goes into both 6 and 2, my final last answers are 3 plus or minus I. Our original polynomial was x to the 4th. We found 2 answers by graphing, -4 and -1. We used those answers to depress the polynomial, and then we got our last 2, 3 plus or minus I. We wanted 4 answers. We have 4 answers. That means we are done. Now, I can throw this whole process in reverse as well. If we look at 37, they give me the answers. Those are the same type of answers we just figured out in the problem before. What we need to do is come up with a polynomial that has those as answers. We've had this before. We start by writing the answers as factors. So 3 becomes x minus 3. -3 becomes x plus 3. With imaginary numbers, they always come in pairs, conjugates. So if 4i is an answer, so is -4i. and I can write them as factors as well. What do you do with all those factors? We're going to multiply them together. I'll use FOIL. So first times first gives me x squared. Outer will be positive 3x. Inner will be negative 3x, which is 0. Then last times last will be negative 9. I can do the same thing with the imaginary ones. First times first is x squared. Outer will be positive 4i, inner will be negative 4i, so they disappear again. Last times last will be negative 16i squared. That becomes positive 16. So far, so good. Now I still have two more things to multiply together. I could use FOIL because they're binomials, or I could try the area model, which you can always do on any kind of polynomial multiplication. Since we did FOIL the first time, I'm going to use the area model this time. I'll take x squared minus 9 and make it the width, and x squared plus 16 to make the length, and then I'll make sure every box is filled in. X squared times x squared is x to the 4th. X squared times negative 9 is negative 9x squared. 16 times x squared is 16x squared. Then negative 9 times 6 is negative 144. So after multiplying all the factors together, we have our polynomial. We've got 1x to the 4th. We have negative 9x squared and 16, so that's 7x squared. And then negative 144. If we wanted to check our answer, our multiplying, we could graph that polynomial, and we should see it cross twice, once at 3 and the other time at negative 3.